Let's go back in time to over 4 million years ago, during the first days of the Pliocene Epoch. The world was undergoing some major changes in temperature and dryness, reshaping the globe. And on the African plains, a new creature was making its mark. It looked somewhat human, but was much smaller and quite unassuming. Despite its appearance, this little creature was extremely important for us, maybe the most important, and it had no idea that it would play a huge role in our understanding of ourselves. Meet the Australopithecus. The first time scientists discovered this ancestor of ours was in 1924, when they found the skull of an infant child in a South African lime quarry. This specimen, now known as the Taung Child, was estimated to be around 3 to 4 years old when it died about 2.8 million years ago. Anthropologist Raymond Dart quickly identified it as a new kind of animal and primate, possibly an early human ancestor, because of its multiple humanoid features. He named it Australopithecus africanus, meaning the southern ape of Africa. Soon after, more specimens of this new creature were found. However, these discoveries, including the Taung Child, faced a lot of backlash from the scientific community. Many scientists at that time were reluctant to see Australopithecus as anything other than an ape. But with more complete remains and increased studies, it became clear that Australopithecus was not just an ape, but an early hominin. It shared traits with both apes and modern humans, though the differences in anatomy were enough to classify it as a separate genus, not a species of Homo. Interestingly, some Australopithecus species were more human-like than others. This sparked debates because there were numerous species within the genus. For instance, Australopithecus gari had more human-like features compared to Australopithecus anamenis. At one point, scientists even considered whether Australopithecus could be a new species of Homo. This debate heated up after a significant discovery in Tanzania in 1935, where 2 trails of footprints were found. These footprints, confirmed to be made by Australopithecus, showed that they were fully bipedal. Because Australopithecus walked on 2 legs, some anthropologists argued it should be classified as Homo, as full bipedalism is a hallmark of humanness. However, most scientists stuck with keeping Australopithecus out of the Homo genus due to anatomical differences, particularly in brain size. Skull scans revealed that the brains of most Australopithecus species were about 65% smaller than those of modern humans. This was a big deal because it challenged the long-held belief that large brains developed before bipedalism. The Tanzanian trackways, dating back 3.7 million years, remain the oldest evidence of clear bipedalism in hominids. The oldest species, Australopithecus anamensis, is roughly 4.2 million years old, making these primates the first hominids to become fully bipedal. Other older hominids like Sahelanthropus and Ardipithecus also walked upright, but their legs, hands, and spines were designed for short periods of bipedalism, spending most of their time in trees. This made Australopithecus the first known great ape and ancestral human to live primarily on the ground. This shift from trees to the ground was a major change. Australopithecus developed several traits to adjust. For example, its legs became longer, stronger, and more human-like, as seen in the famous specimen Lucy. Its feet also evolved, losing the opposable toe seen in other great apes. The pelvis became broader and shorter to support internal organs in an upright position, and a curved spine helped with weight distribution. These adaptations helped Australopithecus walk around. But why did it leave the safety of trees in the first place? This remains a mystery, but the leading theory is climate change. During its time, Africa experienced cooling and more defined seasons, transforming forests into grasslands and savannas. Living on the ground provided access to more resources and allowed Australopithecus to cover larger areas. Despite these adaptations, life on the ground was tough, with an average lifespan of less than 20 years. Adults were small, no more than 1.4 meters or 4 feet 7 inches tall, with females sometimes 50% smaller than males. This small size and lack of strong defenses made them easy prey for predators like hyenas, African wild dogs, big cats, crocodiles, and large eagles. Direct evidence shows that these predators regularly hunted Australopithecus as seen in the damaged skull of the Taung Child, likely attacked by a large eagle. Despite the dangers, Australopithecus managed to survive by retaining climbing abilities. Their curved hands and mobile toes allowed them to escape predators by climbing trees. Juveniles, like Lucy's baby, had opposable toes to help them climb until they matured. Australopithecus also had unique dentition to eat a variety of foods. Thickened enamel and expanded molars allowed them to eat nuts, tubers, and tough grains. They also had enlarged incisors for scavenging meat. Studies show a predominantly herbivorous diet, including fruits, vegetables, and cereal grains. One of the most remarkable traits of Australopithecus was their use of technology. In 2011, a site in Kenya named Lomkwe revealed over 150 artifacts, including stone tools, dated to 3.3 million years ago. This suggests that Australopithecus, or possibly Kenyanthropus, made and used these tools. Evidence from Ethiopia shows that Australopithecus used stone tools to butcher animals, providing access to meat and bone marrow. These tools, along with their bipedalism and other traits, helped Australopithecus spread across Africa, surviving for over 2.3 million years. They coexisted with various animals, including other hominids like Paranthropus and early Homo erectus. Despite their success, Australopithecus sediba became pseudo-extinct about 1.98 million years ago during the early Pleistocene. The exact cause of their disappearance remains debated, with theories ranging from interbreeding and climate change to competition with other hominids. There's also ongoing debate about whether Australopithecus is our direct ancestor. While many believe this is likely, the specifics remain a topic of discussion. Whatever the case, Australopithecus was a crucial part of our evolutionary story, showcasing resilience and adaptability in a changing world. In addition to these fundamental facts, recent research has unveiled even more about Australopithecus. For instance, a 2010 study on the isotopic composition of Australopithecus teeth provided insights into their diet, indicating that they had a varied diet that included C4 plants, which are typically found in open savannas. This aligns with the theory that they adapted to a changing environment by exploiting new food sources. Furthermore, evidence of dental wear patterns suggests that Australopithecus had a seasonal diet, switching between hard, brittle foods and softer, more pliable ones, depending on availability. Another fascinating discovery came from the analysis of their hand bones. Researchers found that Australopithecus had strong, muscular hands, capable of precision grips. This trait would have been advantageous for tool use and manipulation, supporting the idea that they were more than just simple scavengers. They were capable tool makers and users. In terms of social structure, while we don't have direct evidence, comparisons with modern primates and other hominids suggest that Australopithecus may have lived in social groups. This would have provided protection from predators and helped in the sharing of food and resources. Social living could also explain the transmission of tool-making skills and other survival strategies across generations. Australopithecus also displayed a high degree of sexual dimorphism, with males being significantly larger than females. This size difference may indicate a polygynous mating system, where dominant males had access to multiple females, similar to what we see in some modern primate species. Despite their success and adaptability, the world of Australopithecus was fraught with danger. Predators weren't the only threat. Competition for resources with other hominids and animals would have been fierce. Additionally, the changing climate and environment posed constant challenges, requiring continual adaptation and evolution. As our understanding of Australopithecus grows, we gain a deeper appreciation for their place in our evolutionary history. They were not just primitive apes, but complex, adaptable beings that laid the groundwork for the emergence of Homo species. Thanks for watching. If you enjoyed this video, leave a like, drop a comment, and subscribe for for more fascinating prehistoric adventures. Stay curious.